Hello and welcome. Today we are going to discuss the HVAC systems that is implemented in our building. Our building name is Catalyst Building. Let's go through. The air conditioning system used in the building is a centralized air conditioning system with an air-cooled chiller and AHUS, air handling units. This system efficiently cools the entire building by using a central cooling source, the air-cooled chiller, which eliminates the need for a cooling tower, making it easier to maintain and suitable for buildings with space constraints. The chilled air is then distributed throughout the building via a network of 3 AHUs. AHU-1 serves the shopping complex on both floors. AHU-2 serves the second floor startup offices, excluding the shopping complex. And AHU-3 serves the ground floor startup offices, excluding the shopping complex. The cooling is delivered through a supply air ducting system, which carries conditioned air from the AHUS to different zones, and a return air ducting system, which recirculates the air back to the AHUS for reconditioning. To improve energy efficiency and comfort, the system incorporates variable air volume, VAV controls, which adjust the airflow to different zones based on cooling demand. For the startup company space, it is designed that at every branch duct, there will be a VAV box to cater the different needs to the users, just condition at that space. Therefore, at the 10 startup companies, the volume supplied can be increased or decreased to suit the occupant's desire. The conditioned air is distributed through diffusers, while return grills collect the used air for reprocessing. Now let's discuss the E20 form for iMoney Company. The calculations obtained from this form is also suitable for companies like Carsom, iProperty, Policy Street, and BookDoc on the ground floor. It also can be used for companies on the first floor such as Hawuku, Jernexu, Naluri, Kaudim, and Flower Chimp Inc. The area for these buildings are 79.36 meters square. The total sensible heat obtained from this calculation is around 5,743.68 watts, while the latent heat obtained from this is 739.82 watts. Number of occupants that can be occupied in these buildings are around 4 occupants. Grand total heat obtained is 16,780.24 watts. The total heat capacity obtained is 1.4 tons of refrigerant. Next, this E20 form is for droppy. Just as previous form, which can be used for several companies, this form's calculation can also be used for several companies too. Companies such as CapBay, Paywatch Malaysia, and Lapisar.com on ground floor, Pitching Crowdfunding, Pop Meals, Soft Space, and Lottie Flies on first floor are suitable for this calculation. The area of these rooms are 50.91 meters square. The sensible heat transfer obtained is 3,795.32 watts, and latent heat is 501.75 watts. Grand total heat obtained is 11,064.29 watts. The total heat capacity obtained is 0.92 tons of refrigerants. This E20 form here is for Aerodyne Group on the ground floor and Pandai on the first floor. The area of these floors are 57 meters square. The sensible heat gained from these rooms are 3,710.33 watts, and latent heat obtained is 476.76 watts. Grand total heat gained from these rooms are 11,251.44 watts. The total heat capacity obtained is 0.94 tons of refrigerant. The number of occupants that can be occupied is 2. Innovative HVAC systems employ Internet of Things, IoT technology and artificial intelligence, AI, to facilitate real-time monitoring and predictive maintenance. Intelligent sensors autonomously regulate temperature, humidity, and ventilation in accordance with occupancy levels and external climatic conditions, optimizing energy consumption while enhancing comfort. Furthermore, variable refrigerant flow, VRF systems, high-efficiency motors, and variable speed drives, VSDs, are utilized to enhance energy efficiency. Demand-controlled ventilation, DCV, modulates airflow according to CO2 concentrations, guaranteeing adequate ventilation while reducing energy expenditure, and programmable thermostats in conjunction with building automation systems, BAS, provide meticulous regulation of HVAC functions. Next, the HVAC system incorporates solar-assisted cooling and geothermal heat pump technology to enhance sustainability and diminish reliance on traditional energy sources. Photovoltaic PV panels facilitate the functioning of HVAC systems, hence reducing the building's carbon footprint and operational expenses. Moreover, improved indoor air quality IAQ solutions, including high-efficiency particulate air, HEPA filters, ultraviolet germicidal irradiation, UVGI, and bipolar ionization technology, promote healthier indoor environments by removing airborne pollutants and pathogens. Furthermore, the system utilizes thermal energy storage, TES technologies to retain surplus cooling during off-peak hours for application during peak demand periods, as well as waste heat recovery systems that catch and recycle heat from HVAC exhaust to enhance overall energy efficiency. Additionally, high-performance insulation materials, low emissivity, low E, glass windows, and green roofing methods contribute to the reduction of cooling loads. Passive cooling solutions, such as natural ventilation design and shading systems, aid in regulating indoor temperatures while minimizing energy consumption.